It's about halftime at Ignite. How are you feeling? Doing okay? Good level of information? All right. So, typically in sports at halftime you get a break and get to relax a little. Not so much here. We're going to push right through, feed you with more announcements and information. Hear about the new things in the MySQL and Postgres open source offerings. My name is Jan Engelsberg. I'm a program manager in the team that runs the open source databases in the Azure platform. And with me today is Sunil, who is my manager. And so he's basically has even more scope and even more responsibility and really owns actually the program management for the new database offerings. So for the sake of the session, we've thought we're going to take a little bit of a role play approach. So what we're going to do is I'm going to be more like the IT guy in the session, and he's more going to be like the head of IT. So you can see he's like completely different from our normal setup. With him being the manager. But so throughout this session, we'll go through the setup, and hopefully you'll like it. Can I ask, how many of you are developers? Half, okay. And how many DBAs and IT? Okay. Okay.
DevOps.
It's DevOps. Some overlap. That's good. Okay, so let's get started. How many of you have seen these types of questions in your, in your daily or in your average day? Hey, you run a database, right? You have a server hey, is this secure? Do we have a breach? How can we detect if we're being attacked? How can we detect if we're being attacked? Those types of questions come up, and they're not necessarily easy to answer, right, on the security side of things. And then similar set of questions, but with regards to performance, right? Hey, what happened? Things feel slow. Do we have a problem? Why did it degrade? What's going on? And so we're going to try to make things a little easier for you, and today also for me, because I'm the IT guy. I'm going to show you what we have in the service to help you with these kind of things. So with that, I'm going to hand it over to my boss.
Thank you, Jan. So there isn't a day that I don't ask Jan these questions. And actually, I ask many more questions, but he has conveniently not added those questions in the session today. But as the head of IT or head of DevOps, one thing that constantly worries me and keeps me up at night is how secure is my data? Because as the owner of the customer workloads and applications, our customers are entrusting their data and is stored in our database. So I want to make sure that I preserve the trust of my customers and make sure that I have all the controls, policies, and governance in place so that I can build that trust and maintain that trust with my customers. And then similarly on the performance, it's always the total cost of ownership. I am always under pressure to deliver more with less. That's the constant challenge and the pain in which I live in. And that's a good challenge, in fact. So let me enumerate on each of these topics in more detail. And then I'm going to have Jan, and I'm going to challenge Jan to come and give me answers on how am I going to get more sleep at the night. All right. The modern security challenge. There isn't a day that goes by I don't read these reports on my desk. The breaches, the malicious attacks, stealing data, the perpetrators, 75% coming from outside, 25% coming from inside. So they are all over the place, both internal within my organization, outside my organization. How do I make sure that I have the necessary system and operating principles and technology that can allow me to sleep more and make sure that the data is always secure? And this is how I would like to look at the security lifecycle as I manage my database applications. It starts with discovery. It starts with knowing which of my data is confidential and appropriately marked. Establish a security baseline. The baseline against a set of controls and policies that I define. And then, as part of protection, I want to now implement the necessary controls. For example, I want to make sure the data coming in on wire is encrypted and is using the latest TLS 1.2. I want to make sure the data on disk is encrypted so that nobody can access to those data, nobody can access to the data. I want to implement the appropriate access controls. I want to make sure and manage which client IPs can access to the database. I want to secure in a virtual network so that only the trusted virtual machines or those that are running my application can access the data. And then I want to implement the necessary authentication roles so that the appropriate admin staff, like for example, I don't want Jan to have access to the data. I want him to give only access so that he can monitor and tune the database. So I want to make sure that I create those appropriate roles and then manage those roles and users. But then, this doesn't complete the life cycle. What about detection? What do I do to make sure that even though I have all these controls in place, remember the security challenge I talked about. The security challenge where there would be perpetuators, for example, Jan might come in the night, and since he has all the authentication details, can come and access the database and steal data. Or he might give these credentials to a third party. He might sell. I don't know. Right?
I could, yeah.
So how can I detect this? And this could be, I mean, these are not deterministic. This could be from anywhere. Even though I have all these controls in place, I can still lose my logins. I can still lose my passwords. There must be, a user might have a login ID, but they might be trying to do a malicious attack on the passwords, trying to break open the password. That is the challenge I have given to Jan. And come up with a solution so that I can not only detect these threats, but I can take action on it. Because that's when I can sleep at night, because I know that the system is running on my behalf, and I don't have to worry about all these unknown variables that might be attacking my database. So with that, Jan, take it away and give me the solution.
Yeah. Well, let's look at the problem real quick on a more, like on an actual design. Look, what you see here is like a typical setup of an application, right? So you have a front end, you have a set of middleware where your application logic runs, and then you have your databases, right? And then you have a set of back office, people that access the data, do analytics. Obviously, like me, I would do administration, I would do DBA work. All of those are totally legit people accessing the server. So now, the tricky thing is, if you want to monitor what's actually going on, or like basically here, the attack vectors that Sunil just talked about, right? Like, they look very similar, right? Come from the same directions, but they may be malicious. And they may be malicious in different ways. And what you want to do is you want to put a shield around your servers, and a monitoring shield that is able to intercept and look at these different connections coming to your servers and monitor them and analyze them and try to figure out what's going on. And you want to look for unfamiliar locations. You want to look for brute force attack. You want to look at like suspicious users. You want to look for things like SQL injection coming towards your server. And these can come from essentially anywhere, right? And this is really the tricky challenge. It's not like you can't do this today, but it's fairly hard. You need to look at log files. You need to run analysis on top of them. You need to parse all this. You need to try to figure out, well, you know, is this person now legit accessing the database or not, right? How do you do this? How do you build the knowledge? And so lucky me, Microsoft right now announces the availability of threat protection for MySQL and Postgres in preview. And so what is threat protection? Who of you is familiar with threat protection in SQL database? Okay, so 3 of you. That's good, so I tell you something new, right? So threat protection is essentially puts this shield in place that you've seen on the slide before, right? It monitors all the incoming connections to your database, establishes a baseline, right? So when you turn it on, it figures out, okay, what seems to be the normal patterns of the application, and then monitors what's going on compared to this baseline. And then if the threat protection detects something that seems like it doesn't fit into the patterns that were established in the baseline, it will alert me. It will actually send me an email and it will give me recommendations on what to do. And the cool thing about this one is, given that this is being run at scale in the cloud platform, right? There's the ability for threat protection to learn from literally millions of databases, right? So attack patterns, we can learn from millions of databases and apply those patterns against each individual database and essentially make the system every day through machine learning more and more secure by detecting more and more of these patterns and being able to alert on them. Okay, so you want to see it in action?
I absolutely do need to know.
Anybody else?
Excited.
Okay. Let's have a look at it. So the first thing you need to do is, if you have a MySQL or Postgres database or server created, you need to turn it on. And if you go to our portal, there's now a new link here, which is called Advanced Threat Protection. And turning it on is as easy as toggling the switch up here, potentially adding additional email addresses that you want to get alerts on, and saving. So this is all you have to do to turn on the shield and benefit from the monitoring capabilities that Azure has developed and constantly keeps making better. And so actually, during the private preview of this one, I played around with it a little bit. And quickly after turning it on, I got that email. So Mark is actually one of our colleagues. He was traveling in Europe. He was playing, clearly wanted to access the database, and I got this alert, right? I got the, hey, somebody with a legit login accessed your database, but from a weird location, right? Maybe you want to look at it. And it actually tells me at the bottom here, if I zoom in a little bit, it tells me, you should actually look at this, right? Is this something legit? Like, do you want people to access? And then, like, what are also possible remediation steps for this one? It's like, hey, maybe you should lock down your firewall more, right? Maybe the range is too wide. This is why somebody could even access the server in the first place from an outside location. That's pretty cool, no?
I want more.
Okay, of course. Who has ever heard that before, right? All right. So yeah, obviously the email alerts themselves are not all you can do. So this is integrated into the security center, into the Azure Security Center. And what you can do is you can go navigate to the security center, and in the security center itself, so you get nice dashboards, but what you do is you can go to security alerts, and you can then see everything that is going on in your subscription across all the databases, all the servers that you have. Right? So it's one convenient place we can look at and see attacks and look at them in more detail. So for example, seems like there was a brute force attempt. Right? So somebody potentially has the right username, or thinks he has the right username at least, and just starts going through passwords. Right? And so you can see if we select one of those servers, here again, you can get more of the details, very similar to what we just have seen in the email notification also. So you can see, hey, severity is high, right? That's an actual, if we detect a brute force attempt, it's clearly somebody's trying to hack your server, so you should pay immediate attention to it. You can see which server it is. You can see the IP addresses. You can see the principal that is being used also. So if that's a brute force attack and somebody guessed that that's our username, then he should actually get already props for that. But
so that means if someone who has the username and is trying to hack through the passwords.
Yeah, we will know about it.
That's fantastic.
Yeah. And again, remediation steps as we've seen before. And it's just only one of the things we monitor for. You can see in the list here, for example, attempt to log on from a potential harmful application, right? So it's something that's not that's an application that's not typically accessing your database, right? So it's again typically unfamiliar location. Then let's zoom in so you can actually see it a little better. We have more brute force. We have the attempt from an unusual location, so that's the alert that I showed you earlier. We have unfamiliar principal. Right? So somebody is actually trying usernames, right? That typically we don't want to see in the application. Could be like I, as an admin, create myself a user, right? And after he fires me because I messed something up, I just go in and use this user to access the data, right? So these types of scenarios, a user that the application hasn't seen for weeks and weeks and weeks, all of a sudden accesses the database. These types of scenarios that are very hard to detect for yourself are now essentially automated. You will get a notification and you can see it in one place to feel more secure and sleep better at night.
That's good, but I want something more. Now, tell me, I get all these alerts. Does it give me recommendations on what actions I can be taking?
It does, yes.
How do I see those recommendations?
Let's see, like the typical boss didn't pay attention. So it just showed if you go in and you can actually see, when you look at these alerts, you can see remediation steps. Most difficult word I said all day. And so you can see here, like for the one I chose, brute force. So like basically, first thing you obviously want to do is like say, is this actually an attack, right? Look at it. Maybe you have a bug in your system, right? Look at these kind of steps. And then, again, make sure you actually lock down, right? A brute force attack would typically come from somewhere like outside of your organization, from an unusual address, somewhere outside. So make your server more secure, lock yourself more down. Is one of the first immediate steps you would take here to essentially stop the immediate attack from happening.
That's good. So that means I got 2 hours of my sleep back. But again, I want more. Now, tell me about, this is another scenario that I'm really worried about, is I always, like, for example, as much as I want to trust you, but I don't. But you might be running some SQL commands, you might be dropping tables, you might be altering roles. I want to be able to track and audit that. What are you thinking about? I mean,
yeah,
when are we going to enable that?
I guess you're asking about auditing, right? Auditing is not yet part of this, but I actually have a good connection to the engineering team. So I know that guy, he's called Sudhakar.
Oh, yeah?
Yeah, he's a GM of the team. In fact, he's sitting up there, and he told me that they're working on it actively, and towards the end of the year, we'll have auditing for both MySQL and Postgres as well. So then we can, I guess, finally get some sleep.
I'm looking forward to that sleep.
Me too.
Good.
All right.
Thank you, Jan. So now that we went through this, like addressing how do we go about addressing the security challenge, now I want to throw another challenge at Jan, right? He's a tall German lazy guy, so I need to keep him busy. And one of the other things that I talked about that is important to me is TCO, performance. Because I get constantly asked by my business users in delivering the best performance for the applications. Because for the business, if the performance is not meeting the end user requirements, that potentially means a churned customer. So how do we make sure that my team has the necessary tools in place so that they can investigate and then they can optimize the performance? But guess what happens? Every time Jan comes and tells me, he just gives me excuses, right? He says it's difficult, it's hard, it's an art, it's not a science. And I don't believe him. But then I challenged him, and then he came up with another excuse. And he doesn't know that I'm showing this chart. He gave me this excuse saying that, hey, I have this Postgres database, I have to go through this 20, 30 different Postgres views, try to analyze and make sense of all this data, and then by the time the event has already happened, I can't react to it. All right, work harder. What else can we do? And then he comes and says, the application team did a deployment. They changed the patterns. Or he will come and say, it's all the application developer's fault. It's not the database fault. I tell him to go and talk to the application developers. He says it's the database fault. Right? So then they're in this ping pong game all the time, not talking the same language. And more importantly, the event that has already happened, there was a performance issue that led to hundreds of users churning away from the application because it was giving a bad experience. And now I have no way to go back and check what really happened. So I told Jan, if he's not going to solve this problem for me, then perhaps I should look for another admin. So he said, I'm going to go work hard and try to find a solution. So here he wants to come back and present what the solution is. Jan?
All right, I'll try. I have to go back to lazy and German. That doesn't seem to fit at all, actually. Okay. But fair enough. If that's what he thinks, I need to change some stuff. But so here again, right, the good news is, right now, Microsoft is announcing intelligent performance in preview for MySQL and Postgres. Who's familiar with that from SQL Database? So that's only 2 this time. Not 3, okay, but different 3. That's interesting. Okay, so what is intelligent performance? So what we've done is we have taken some of the concepts that were introduced in SQL Database, and I've brought those to the MySQL, to Postgres. And there are 3 key components that play a role there. The first one is what is called a query store. And I'll talk about it in more detail what this is. So this is essentially the foundation of it. And then on top of this sits query performance insights and performance recommendations. And the whole idea here is to make basically what you've seen on the previous slide, right? Looking at log files, looking at stat statements, looking at like what are the resources, how is the resource utilization, all of this stuff. Bring it all together in one place and give you the insights from there on. And the idea here is not only to give you the insights, but put intelligence on top of it. So what we do there is we analyze these insights and the data we have gathered and give you recommendations on what to do.
So Jan, you say without the need to be an expert, that means I can fire you?
No, that doesn't mean you can fire me, because I'm the one who knows how to do this. And I'll share it now, and then you can probably...
Better yet, I guess you're saying that you can now be an expert, and instead of playing the ping pong game with the application team, you can actually work in collaboration.
I think about it more like I can sleep at night now. Yeah. So let's have a look at Query Store. So what Query Store does in Postgres is we have actually hooked in with the hooks that Postgres provides, and we gather statistics on queries that run. So we take the queries, and essentially we remove all the variables of the queries themselves so that we're able to group the queries together. So think of it as like you have a select star from foo, where a equals 1, we would remove the 1 because that's the piece that keeps changing all the time. And we say, OK, this query pattern is 1 query, and we're going to start gathering statistics of this query. And so what we do is we take this pattern of the query and start aggregating over windows of time in memory. We're going to start aggregating statistics of the query. So something like how many times was it executed? What is the average, what is the execution time? And then we calculate what is the average execution time, what is the standard deviation. We look at the weight stats for these queries so that you gain insights into, hey, what's actually going on with that query? And we put this data all together. And what we do is, and that's actually the key of this query store, is every 15 minutes, you're going to take this data and persist it into a new database that we have put into Postgres in our service. And what this gives you is the ability to look at the data over time. Right? And this is something that you couldn't easily do in Postgres until now. Right? So having the view, the ability of going back and say, hey, what actually happened yesterday? Right? What happened half an hour ago? What did the query do 15 minutes ago? Right? What did change? So this is actually the key thing that Query Store enables you to do.
What about 2 weeks ago?
2 weeks ago will also work.
What about 30 days ago?
30 days will also work. We actually let you configure the duration, how long you want to keep the data from 7 up to 30 days. And it's actually on this slide, as you can see. I'm very well prepared. So the key here is we try to keep it as familiar as possible to people that know and run Postgres. Right? So we didn't invent new column names. We didn't some obviously, because we do the aggregated statistics on top of it, but everything else is very familiar. So we reuse the schema, for example, of pgstat statement, and you will see this in a moment. We use the pgweight sampling schema, right? So the idea is like there should be all close to 0 adoption hurdles for you to run your previous queries that you have and use this new tool. Then the next thing I already said, we run all of this in memory, and we specifically focused on making this as performant as possible. And piece of it is having these 15-minute windows and aggregate the data in 15 minutes all in memory and then only then write it down to disk. to get these chunks over time. And again, it's also that it's a minimal invasive analysis on top of your existing workloads. Then,
so I have a question now.
yes, sir.
What's the performance impact for enabling this?
For?
What is the performance impact because of all these other things that are behind?
Well, it's minimal, and you actually get you have the option to also tune how much impact. Obviously, it can never be zero impact. Because we need to gather statistics and do some aggregations. But you can, with the tuning parameters that are exposed in Query Store, you have the option to basically tune this and make this optimal for your workload. We give you different capturing modes. So you can only capture the top queries. You can capture all the queries. And specifically for sampling the weight statistics, we let you configure what is the sampling frequency at which we look at the weight stats and gather the weight stats and aggregate them. And it's critical because if you can imagine if you want to do an in-depth analysis of what's going on, you probably would want to set the weight sampling to 1 millisecond and get as many samples as possible to do a deep dive investigation. Whereas, hey, if you just want to monitor your workload over time, maybe you put it to 100 milliseconds, 200 milliseconds, whatever seems right to get a sense for what's going on. So Query Store gives you this flexibility. Nice. OK. So a few scenarios that Query Store enables. Obviously, workload tuning comes into mind, right? What are the longest running queries? Identify some of the queries that use the most resources, right? And again, as I said before, the key thing is you can do this over time, right? Once a day, you can go in and say, OK, let's look at the entire day. Let's see what was hurting me the most today. And then you can go in, look at the query specifically, see why the query was slow, and then try to modify that query and try to essentially make your workload better. And it's specifically interesting if you have a lot of ad hoc stuff going on that happens now and then, but is also repetitive over time, because these kind of queries are very hard to capture. Like if you have to go into the system and monitor the system actively to see what's going on, it's much harder than if you can come at the end of the day and say, OK, what happened today? Look at the data and see if there was something new happening, what was expensive, did something change, all of these kind of things you can see. And in addition, what it allows you to do is it actually allows you to do essentially an A/B testing, right? You want to make a change to a schema. What is the impact of the change to the schema? Well, now you can actually observe it. You can look at it. What was the performance before of the queries? What is the performance after? And that's some of the key benefits of having this time series of data and performance data in the Query Store.
So two of the most important scenarios that I can think about here. Number one, typically, whenever we have talked about performance, you have always said, throw hardware at the problem. And now I can really validate whether I should really throw hardware at the problem, more resources, and therefore increase my spend, or I can perhaps now use the tool and see whether I should tune my database.
Exactly, and hire more DBAs.
Fantastic.
Think about it.
Show me how it works.
Yeah, let's have a look at it. So the first thing you have to do is turn on the Query Store. And I have a Postgres database right here. And what I'm going to do is I'm going to go to the server parameters. And so this is the place where you configure the parameters that I just talked about. And so just take a second to load. And what we do here is just search for PG. And it will list, plus one or two others, it will list the parameters that are essential for Query Store to be configured. So you can say, what is the max length of the text that we look at the query text? So the 6,000 characters that you see here is what the default value is. And we put this default value in based on what we have seen in our service running. So 99% of the queries actually fit into this one. There's a little bit of a trade-off you have to do, because the longer the characters get, the more overhead is there in memory, and ultimately the bigger is the impact. Then you can set the capture mode. You can see it's set to all here. So that means the Query Store is already running for this database. You can configure the retention period. You can say, hey, should we track all the utility queries that run, like that basically Postgres runs? And then PG stat statement, I turned off here because we actually don't need it anymore, because Query Store does this for us. And then I talked already about the sampling period. Right now it's 100 milliseconds. And then you can also turn on and off the sampling individually of capturing the execution statistics and other statistics that we gather on the queries themselves. So you can separate this out. So that's the first step. As I said, it's already done for this server. And now let's have a look how this looks in the server itself. So I'm connected to a Postgres server right here. And in this Postgres server, there's a new database called Azure Sys, which is where all this data is stored. So it goes in the service, it goes against the quota of what you have provisioned, but it's in your database, it's in your server. And then there's a schema called query store, and in this schema, there's a set of views. And the main view here is the one that is called QS_view, which is the query store view. So just running a select star on this one. Okay. Let's be connected.
This is running slow. Okay.
Yeah, sorry. I'll tune this later.
Sure.
Yeah. So just what I want to show here, like it's not so important what queries are running here, right? But you get a sense for the schema that's in there. So you get the query text, you get a plan ID, you get the start and the end time of the interval that this query was observed. You get the total calls, so the executions of the query. You get the total time, the minimum time, mean time. So these are these statistics that I said earlier we calculate on top of the query. And then, in addition, you get all the other information that you know from stat statement, for example, right? So you can look at how were the buffers hit, like how many reads did I do. All this information is in a familiar schema also in this view.
So rather than having to go and look at 20, 30 different Postgres views, I have all the data that is stored in time series format and in the Azure Sys database.
Yeah, exactly. So now, obviously, the question is, so how powerful is this? And you already said the example. Typically, I tell you we need more resources, right, to make it faster. So we have a database. So this server specifically, we had originally set up so that the entire data set is in memory so that we don't really hit the disk and do any I/O operations. And so what we can do here is run a query. And what this query does is it looks at the cache hits versus the cache, or basically like it looks at how many hits in the cache were there and how many pages were loaded from disk and calculates a ratio of this one. And if we had done our homework correctly, then it would be 100% cache hits. And so essentially what this query does is it looks over time and calculates where we stand. And you can see here in the results, I need to expand this a little bit. You can see here in the results, we're not looking that good. So we only have about 87% of cache hits for this query. So what this means, I was right, like usual, right? And we should actually have better hardware and more memory to fit the entire workload basically into memory so that we don't hit the disk. And you can see it wasn't always like this. So if we scroll a little further down, you can see the cache hit percentages were higher because there was less data in the database. And in the very beginning, we were actually very close in achieving our goal by hitting 100%, like at the very bottom. So initial sizing was good. There was a little bit of a drop-off. It goes back up. But so you can see how powerful this is to look at this over time and see what's actually degrading.
So likely, the new rows or new data has been added, and therefore perhaps maybe we have a tuning opportunity, and that's good. That could
also be the query changed over time, and queries a wider range. But yeah.
So now are you telling me again to scale up to a higher SKU?
Absolutely. Good. Yeah. So that was only the first step. So now you can say, okay, like, sure, make my life a little easier. It's a little more powerful. Like I got some more tools to the work. But how does the service help me to, sleep more, like have a little more free time, play more games at work, right? So we do here, this is where query performance insights and performance recommendations come into play. So the query performance insights at a first step is essentially a visualization on top of the data that you just seen, right? And I will show this to you in the next demo. You can go to the portal and see, hey, which queries were running, which ones were the expensive ones. And so it's essentially making, it takes away running the queries, and it's an easy, like one glance at it, you can see what's going on thing. The second thing, and that's the more powerful piece of it, and that's where the intelligence comes into play. What we do is we run analysis on top of the data that's in your query store, and we try to figure out if there are optimizations that can be done to your schema to make the queries performing better. And the first thing that we've done is we have put in logic to do index recommendations. And so how this works is we look at the data and see which are the queries that are very I/O intensive. And we try to figure out why is this the case. So we look at the, essentially at the where clauses and see, okay, are you filtering on certain columns? Do you do lookups, et cetera? And is there potentially an index that could help this query to run faster? And what we do is we take the initial query as a baseline, and then we put in hypothetic index on top of it, and then we look at how would the query perform with this index in place. And you can do before and after comparison. And if in the initial comparison, the performance of the query would be better with the index, then we're going to continue to look at, okay, what is the impact of putting the index in place? Because obviously, as everybody knows, there's a trade-off, right? You put an index in place, well, the read operations may be much faster, but hey, if you insert a lot, then that's maybe not that good of an idea, right? So there's a trade-off to be made. And what the system does, it looks at all the queries that hit the table, looks at all the queries that could potentially benefit from this index, but it also looks at all the queries that would be impacted by the index being in place. And it will find a balance, and it will make a recommendation if the system thinks that overall, across the entire set of queries that have been looked at, this index is beneficial.
I can't wait to see it.
Yeah, you'll be surprised how easy it actually is. So let's look at it. As I said, the entry point here, we put all of this into the portal. And the entry point is down here. You click on Query Performance Insights. And what you can see here, as I said, is like a visualization of essentially a period of time that we're looking at. And you can see which are the most expensive queries. And all the Postgres experts, what workload is this?
Favorite PG bench.
Exactly. You can see, right? Update PG bench accounts. Most Postgres people will know this. And you can see, hey, this query over time seems to be running very long. The unit on the left on the scale is actually minutes. And so in these intervals, this query is running very, very, very long. So that's an indication for something is wrong. So now, for example, at 6 o'clock, right? So now the question is, what's going on? And so what you can do is you can go into the wait statistics and have a look at what is this query waiting on? What's going on in the system that is potentially blocking this query from making progress? And looking at 6 o'clock again here, that's, I guess, 6 o'clock somewhere here. Doesn't matter, they're all bad. If you look at it, you can see, let me scroll in a little. That doesn't work. That's too bad. I hope you can see that pop up. But basically what it says is the blue line at the bottom there is the wait, the thing that the query is waiting on is buffer I/O. That's an indication for the query is hitting the disk a lot and needs to read a lot and is waiting for I/O operations to finish. And
is this buffer I/O something Azure Postgres uniquely identifies, or is this the standard Postgres?
These are standard Postgres. And we actually have a link here to the wait stats. You can click on the link to get all the wait stats. So this is just the Postgres documentation, and all the wait stats that you will see here will ultimately flow into the query store. There's nothing new we added.
That's great. So that means you don't have to learn something new.
Exactly. That's exactly the idea. And so clearly there's a problem with the query, and well, maybe an index would help. And this is the cool thing here, is you can click on performance recommendations, and you can run an analysis on top of the query store. So this doesn't happen automatically in the background because obviously this consumes resources. You have to click the analysis button, and it will run an analysis. And that takes a few moments, which is why I've run it before. And you can see here, indeed, there's a recommendation to create an index. And it is the index on the accounts table. And so what the tool has done here is it has looked at the queries. They are mostly select queries. There are a few updates also that can benefit from the index as well, because there's a lookup that needs to happen, right? And the tool overall has decided that having this index in place will help. And then the only thing you need to do is copy the text and execute it in your database, and you're good to go.
I also see that it gives me estimated index size.
Exactly, yeah. So you also get a sense for, hey, what is the cost of adding this index? And we are in the process of adding some smarts of giving you an indication, like a low, medium, high, of how impactful this index can be to your application. It's like high impact is like you will get significantly better performance and so on. So you get an idea if you have a lot of recommendations, hey, which is the recommendation you may want to pick first because it has the highest impact in optimizing the performance of your workload.
Thank you, Jan. Great job.
You're welcome.
So in summary, Azure Database for MySQL and Postgres is now more intelligent. So the key things that I kept worrying about, security and performance, now it's available on my fingertips. So my staff, like Jan, can start to become productive, and I can, as the IT chief, can serve my business users with a lot more confidence and and meet their total cost of ownership. So with that, thank you for listening, and thank you for participating, and we'll open up for questions. That's a hard question, Jan.
Oh, I get to answer the hard questions. Which you mean the query store? Either. Okay, so the threat protection is available on MySQL as well. The query store, not yet. There is cost to threat protection, yeah. So there's a fee per server that you have to pay, and that's the same as for SQL database as well. And it's like while it's in preview, you get a 50% discount, but at GA, it's going to be $15 per server. There's no cost to the query store other than the fact that we obviously store the data in your server, so there's a little bit of overhead that you have on storage and compute, obviously.
But the intelligent performance we talked about is completely free.
Yeah.
Yes. Yes. So threat protection is what it is allowing you is it is giving you detection, right? It's not prevention. So it is learning through the patterns, the access patterns coming to the database and alerting you and giving you recommendations on what actions you can take. That is where you need to then work to actually create more tighter security controls. For example, access management, firewall rules, and so on.
So I think maybe we can actually take the design a little further offline. But basically, how this works in our service is you always you always connect to the database through a proxy. So you never have a direct connection, right? So there's actually no way in bypassing this in the first place. Yeah, you can think of it this way, yeah.
Any other questions? All right, thank you, folks.